Broadcasting live from our studio in Boston with presentations from prominent industry vendors, Solutions Review presents Data Demo Day, an online event for data management and analytics.
I'm Doug Atkinson here at Solutions Review, and welcome to Data Demo Day. For this edition, we brought together 4 of the hottest data and analytics solutions coming out of Silicon Valley. Let's move on now to our next featured solution, Decodable, an aptly named company, as their mission is to make streaming data engineering easy. As a serverless platform for real-time data ingestion, integration, analysis, and event-driven service development, Decodable eliminates the need for a large data team, clusters to set up, or code to write. This new approach puts the power of real-time data engineering in the hands of every developer, meaning engineers only need basic SQL skills to connect sources and data sinks, build and deploy real-time pipelines in just minutes, and easily manage those pipelines. And joining us from San Francisco is the CEO of Decodable, Eric Sammer. Eric, thanks for being with us.
Thanks so much for having me. I really appreciate the time.
Well, I can't tell you how happy we are to have Decodable as part of this demo day, and more particularly, how happy we are to have you as CEO being a part of it as well.
Yeah, absolutely. My background is more on the engineering and product side. So I come from a world of building high performance database engines, stream processing systems, general data infrastructure. And throughout the course, I've been doing this for, 25 years, give or take. And in 2010, starting with Cloudera, where I was an early employee, and sort of everything kind of after that, I've really been working with a bunch of data infrastructure, like the folks at Sigma were just talking about, data warehouses and database systems and those kinds of things. And every customer we talk to has like this ever increasing number of source systems and destination systems, and data is in different formats, and it's owned by different teams. And I think like over and over again, between Cloudera, my first startup, Rokana, Splunk, which acquired, Rokana, my first startup, and now Decodable, we have seen customers over and over again just struggle with getting access to the right data, getting it into the right format, and then getting it into the system that someone needs in order to make that useful, whether it's something like Sigma or whether it's powering real-time applications like fraud, waste, and abuse, or dynamic pricing systems, next best offer, those kinds of things in various industries like retail, logistics, so on and so forth. So we just kept seeing this problem over and over again. And I'll be honest with you, I just don't think it needs to be as hard as we make it, and really wanted to provide a platform for data engineers and application developers that were building these real-time platforms, both operational and analytical.
Yeah, I think this is what we're seeing as we've been covering these spaces for so long now. Is the first gen is, can we even do it? And second gen is, now that we can do it, how can we make it easier? And ultimately build tools that really unlock the power of a lot of the technology, because I think that has been a limiting factor. I'm going to let you jump in and show this, because it's an incredibly compelling solution. And I'm going to let our audience know that if they have any questions, to submit them. We'll hold them until the end. We'll save 7 minutes or so, 5 minutes or so at the end to go over some questions with Eric. But otherwise, Eric, the floor is yours. You have 20 minutes to kind of stretch your legs and show the whole Decodable solution. So I'll see you in a little bit.
Yeah, absolutely. Well, I really appreciate the time, everybody, today. I'll show you just a couple of quick slides just to kind of set things up. And I won't go into a ton of detail here. I'll just say that, Decodable is really built to be a real-time platform and power the real-time applications, like I said, sort of both operational systems, things that are customer-facing, think real-time package delivery or customer analytics, that drive online product recommendation systems, ML feature stores, those kinds of things, and also offline or back office type stuff on the analytical data plane, so the data warehouse, data lakes, and any internal data infrastructure that is powering, decision making or offline model training and all those other kinds of systems. And fundamentally, at our core, what Decodable is really all about is providing that that full feature platform. For us, that means the ability to connect to all of the data infrastructure, whether they're operational databases like Postgres and MySQL, Mongo, whether they're event streaming platforms like Kafka, Kinesis, Pulsar, Red Panda, so on and so forth. We talked about data lakes and data warehouses, and this increasingly wide, diverse set of specialized database systems for serving things like what some people call real-time databases or user analytics or OLAP databases. So Apache Pinot from companies like StarTree, Apache Druid from companies like Imply, and Rockset, you name it. There's just like an endless landscape of really, really exciting databases to drive different kinds of specialized use cases. And that would include full text search systems like Elasticsearch and OpenSearch in that list as well. So Decodable integrates with all those systems and then allows you to process the data as it moves between those systems. And I think more so than just being fast, it really needs to be easy to use. And so it's really built for anybody who knows SQL. It's built on top of the best of breed, what we believe to be the best breed open source stack for real-time data. That includes Debezium for change data capture. That includes Apache Flink for high throughput, scalable, stateful stream processing. I'm going to show you more, in detail about this. It is a managed cloud platform, so there's no sort of setup, deployment. It comes batteries included, ready for you to be able to build these kinds of applications quickly. So I'll spare you any more slides, and maybe we'll go straight into a quick demo here. So what I'm actually going to do is switch tabs real quick. What I'm actually going to do is show you very briefly inside of Decodable. So I'm inside of a test account, and what I'm going to do is I'm going to take you through an end-to-end example where I'm connecting to multiple data sources, one of which is a Postgres database, operational database that has a product table in it. And we're going to insert a couple of records into it and sort of see, change data capture, sort of take those records, or CDC, take those records, bring it into Decodable so that we can use it for joins and lookups and enrichment of clickstream data. And on the clickstream side, just for the sake of simplicity here, I'm using a data generator that is outputting what looks like HTTP clickstream data that you might get out of any kind of REST service or web application, but it could really be any kind of event. It could be, package scan events. It could be purchase transactions. There's all sorts of, so don't think that it's necessarily just about clickstream data. So in Decodable, you can connect to all of the source and destination systems that you have. We have a bunch of built-in connectors. Like I said, I'm going to be using our data generator that's built in that you can play with yourself, and also Postgres on the CDC side. But we also include support for, like in the last presentation with systems like Sigma, whether that's powered by something like Snowflake or Databricks, with data stored in Delta Lake. It can also come from a variety of other systems. So you get some sample of like the kinds of systems that we support here. Here I have a Postgres connection that has some just basic connection information. So this is the extent of configuration. The host name, I'm using RDS in Amazon. Database table, in this case, I'm connecting to a products table you can see here, and some credentials. And that's really it. The rest of it we are going to deal with. So we've actually learned the schema from the database system. So we have, an ID, a name, price of a product, and what kind of stock we have on hand, and the last updated time. And in fact, in another window here, I have that Postgres database, and have all of those fields here available. And so you can see that there's actually nothing inside of this database table today. So this connection has what we call a task associated with a medium task, and we're actually reading data in real time from this. And it's going out to what we call a stream. Today, it's empty because there's no records in the database. And you can see some lineage information here. I'm going to get into pipelines in a second, which is where you can express your processing logic and be able to transform, aggregate, enrich, join all sorts of different verbs, your data there. So I'll get into that in a second. Excuse me. So what I'm going to do here is I'm actually just going to, I have a couple of different quick queries here. I'm going to insert just one row to start. And you can see I'm just inserting a PlayStation 5 record. We have a product ID, a price, and my update time is going to be now. Whoops. Quotes got messed up. So this is just going to be a really simple record for us. Oh, all right. I'm just going to type this, insert into products, values. Sorry about this. And we're going to say that this is our PlayStation 5, $599.99. We have 5 of those in stock, and it's updated now. So we can now see that we have our record here. And so if we sample, the preview, we can see that Decodable has picked up this record, and it has here this notion of historical values. So this is effectively a materialized table. So basically, it's replicating this data from Postgres so that we can use it for stream processing. We can also look at the underlying change records, where you can see all of the details. I think this is actually outdated. Yeah. So we can see all of the different change records, and these are in Debezium format. So for those of you who know Debezium, this is going to look really familiar. And we have this record here. And just to sort of show you that it sort of works the way you think it does, I'm going to update this products table. I'm going to set, I'm going to set stock to 4, and I'm going to set updated to now, where ID equals 1. And it can take just a quick sec to show up because we're doing exactly once data processing. So this might take just a second to pop up, but the system's actually processing data, in real time. So now you can see sort of the change that's occurring under the hood with the different versions of the records. The current version is 4. It went from 5 to 4 in stock, and our update time changed. And so what I want to do very quickly is show how we can do things like detect stock refreshes. So here's where we're going to get into a pipeline, and this is where the interesting stuff starts to happen. So I'm expressing this in SQL. I have a pretty simple SQL query where we're inserting into our output stream stock refreshes, and we're using a common table expression, or a CTE here. Our stock changes, we're actually going to take the change data capture data that we have coming in from our source, and we're going to unroll it into the individual events because we want to actually see the changes that are occurring in that table. And that actually gives us access to the both before record and the after record. So we can actually see exactly what the old value and the new value were, and we get the operation. So again, if you're familiar with Debezium, these are actually the fields that you get out of a Debezium change record. And what we're actually going to do is we're going to look for cases where the after stock value is greater than the before stock value, and also greater than 0, just as like a quality check to make sure that we don't go into negatives or anything like that. And the interesting thing about Decodable is that we can actually preview what this query is going to look like. So I'm actually going to start a preview. You'll see that the system says it's waiting to receive results. This condition hasn't happened, so we're not going to see anything. But let's say that our stock value falls to 0. Again, we're not going to see anything because our predicate is looking for the case where after is greater than the before. And so what I'm going to do now is I'm going to say, let's say we received a new shipment of PlayStation 5s and we want to trigger marketing campaigns or re-engage abandoned cart users or something like that. And so what I'm going to do is I'm going to refresh the stock to 10 records, and we can see now that we received an update of product ID 1, PlayStation 5. Our before value was 0, and our after is now 10. And you can see exactly when this occurred. So, and I'll step into this in just a sec, but you can see how you can create triggers and event-driven microservices, and even product recommendations that are occurring in real time based on sort of what's happening with inventory and stock. We can also see quite a bit of detail in this, if we wanted to, in sort of different ways of being able to aggregate and process this data. But this is just like a quick example of what that looks like. This pipeline is actually already running. So what I'm actually going to get on the output side, our output stream contains that record. And so it'll continue to receive updates as they occur, anytime the stock is refreshed on any product, which will allow us to do all sorts of interesting business processes downstream of that. Next, I want to show you something simple. So this is just a data generator that is generating Envoy proxy data every 100 milliseconds. And so basically in our output stream here, you can see that we're actually getting raw text records, every 100 milliseconds or so. And these are unparsed. They're not particularly usable by anybody within the organization unless you really know about the format of Envoy proxy data. So we're going to make this useful for people downstream of us. And you can see that I have 2 pipelines hanging off of this. I'm actually going to look at this parsed HTTP events pipeline. And here, again, slightly more interesting, we're using a CTE. We are parsing using Grok expressions, which is just like regex on steroids, right? So we're taking, a bunch of different fields out of the record, but we're also preserving the raw record. So what we're going to get out of this portion of the CTE is a series of parsed records, and then we're normalizing those by casting to different data types and stuff like that. This is like your classic streaming ETL style use case, and again, preserving the raw value. So our output is going to be this normalized value. So again, we can run a preview real quick, and this will attach to the real stream in real time. It will show us this data as it's flowing through the system. So you can see that we're actually getting the right values out. You can see that our casting is working. You get a sense of everything that's included here. And of course, Decodable has a fully featured SQL engine. So for instance, if you mess up your parsing rules or something like that, and you get like the timestamp format wrong, which winds up happening to a lot of people, you'll actually see that, in this case, it actually still is processing. Let's see if we can do this. You'll see that we might not be able to parse any of those records. So in this instance, we have null timestamps. So you actually know, hey, my records aren't sort of aren't looking the way that I expect. And again, I have this query running, and it's producing its output here. So we have this, and you can even see that we have one more. Let me go back one, sorry. You can see that we have this output stream is feeding yet another pipeline. And in this instance, let's say that we wanted to calculate view stats. And so this is like slightly more interesting. So what we're actually going to do in this case is create a data set that is showing which products are being viewed, and enrich that stream so that it can be used in systems like Snowflake and model training, for understanding what products are interesting. And so what we want to do is we want to join that clickstream data with the product data that we are ingesting. And in fact, what I'm going to do real quick is I'm going to insert 2 more product records. So what I'm going to do is I'm going to create product 2, and we're going to call that, an iPhone, and we'll create a iPhone case for product ID 3. That would be a very expensive case. Let's say that it's actually, I don't know, 2753. And so now our table has multiple products in it. And what I'm going to do now, so the system will pull those things in just as it did the other records. So what I'm going to do is I'm going to create what we call a tumbling window. So every 10 seconds, we're going to group by the window, the 10-second window start and end time, the request method, and the request path, and then the response codes. We know whether or not that HTTP request was successful. And we're going to count those events. And we're going to filter for just the events that are product references and HTTP GET. So these are basically people viewing the products. And in this case, we filter out just the successful ones. And then what we're going to do is we're going to split that path and extract the product ID from the URL path. And then we're going to join the results with our product CDC stream, right? So relatively straightforward stuff. And then what we'll do is we'll create an append stream off of this so that we get a time series output. So what I'm going to do is I'm actually going to start from the earliest position in the stream. So it's going to rewind in time and pick up all of the changes that we saw. And then I'm going to run this preview, and it's going to take a second to fire up and start doing the joins and aggregations. And what you'll see is that every 10 seconds, we get a new set of records with the path that was requested, but now we actually have product information inside of this, right? So we actually know the product information, we know the stock as it was at that particular point in time, and when that product record was updated. So again, we're doing this all in real time. We can actually take this, and if we wanted to, we can write this result to any one of these syncs that we have. So whether we want to use something like implied Polaris with Druid or Snowflake, or maybe you want to index that information in Elasticsearch, that might not be interesting in this case, but we could also write that data into Delta Lake. And so here, you just specify your S3 path and then ARN, a role for us to assume, and we'll handle all the authentication information from that. So you can actually complete and fan this data out to multiple different use cases. And what you can see is that throughout that process, we've been able to create a series. Well, one, we have things like lineage information. So you know that this product view stats comes from these 2 streams. And we've made these streams available for anybody else within the organization to be able to use. So we can do all kinds of, powering of different kinds of operational and analytical applications. So hopefully this is interesting to you. We see a ton of use cases across logistics with shipping and receiving, think food delivery and location data. We see obviously tons of clickstream, retail, customer 360 style use cases. Obviously just ingesting data into analytical systems for business intelligence and back office reporting and just understanding what's happening in the business. Offline model training. So data science and ML engineering teams can use Decodable to be able to do feature extraction and build time series data, different kinds of metric data inside of feature stores like Feast, or maybe you're using Redis directly, those kinds of things. We can even feed this data back into operational systems so that people can do all kinds of really exciting things. So I'll sort of pause there.
I want to point out that folks should definitely go to decodable.co,
Yes.
and there's just so much information on there. Lots of resources, lots of documentation, lots of information, obviously, about products and solutions, and even a request a demo call to action in there. So with that in mind, while we have a few minutes, I'm curious who you want to engage with within an organization as an ideal, right? When somebody
Yes.
actually the requested demo lights up. I mean, who are you looking for? Who do you think is kind of the most appropriate people to connect with within an organization?
Yeah, I mean, so the people that tend to engage or sort of see the most value are either the technical architects or leaders around internal data platforms. So the people who are choosing solutions and building, providing this kind of platform to the organization, building this platform internally, and then of course, like this typically is part of like a CTO or a VP of data platform, it's typically like in that part of the organization. But the end users that wind up using Decodable, whether it's through the web UI or our DBT adapter and those kinds of things, tend to be data engineers and application developers. And the goal here is to make them self-service. I know we abuse that term a lot, but the goal is to make them self-service within the organization so that they don't have to, learn the low-level details, of things like Debezium and Flink and Kafka, if they don't have the time or the wherewithal there.
Well, and with regard to testing things out and a proof of concept, I mean, what can you set for an expectation with regard to some sort of a timeline around a proof of
Yeah.
concept, or at least getting some tool set in place so that people can play around with it?
Yeah, absolutely. So, I mean, we are a managed service, so there's nothing really to deploy. That's, I think, really, really exciting for people. So that typically means that you can kind of get up and running pretty quickly. We typically see POCs be about a week, a day of which is connecting to all, setting up the connections to all your data infrastructure, depending on how many connections you have. And then for anybody who knows SQL, from that point on, it tends to be really, really straightforward. I mean, you saw some of the examples of sort of what we've been able to do just in a short amount of time. Usually we've seen people build out a couple of use cases within that first week and be up and running and sort of, off to the races from there. At which point, they might open it up to a larger team to get started. Like you said, people can request a demo, but there's also a free trial tier. So you can actually just use Decodable today. You don't have to spend any time sort of talking to us, to get up and running. So I think that's really exciting, especially when coupled with trials of other systems, whether it's Snowflake or Sigma, some of the other demos that folks are seeing today.
And with regard to kind of hand holding, I mean, self-service is a wonderful thing, but sometimes it's nice to have somebody who can kind of help them
Yeah.
extract a little bit more value. I mean, what is the kind of that initial support structure look like?
Yeah, absolutely. I mean, we always have community support available to everybody, including those folks on the free tier, forums and Slack level support. For anybody who's engaged in like an active POC, we are more than happy to help out. So typically what we do is we create a shared Slack channel with customers and just be able to communicate back and forth and answer questions in real time. We sort of subscribe to doing everything in real time here at Decodable. So we like to be able to engage and just help folks out as they go through the product and hopefully they don't run into any issues. But typically sometimes people have a question or two about how to express a certain kind of business logic or something like that in SQL. We're happy to help out.
Well, this was great. Eric, thanks very much for that. Best of luck with the rest of the year. And certainly as you grow, we'll be keeping an eye on you here at Solutions Review. Thanks.
Yeah, really appreciate it. Thanks so much for having us.
You bet. Well, there you have it. That's Data Demo Day. We had 4 great solutions and really great presentations. We want to thank you all for your participation as well, for sticking with us through the whole thing. Until next time, I'm Doug Atkinson here at Solutions Review. Thanks for watching.